They're, we're talking about lighthouses and beacons, light characteristics and where they come from. And then we'll do a little bit about meteorology, the sources of meteorological information that we can get, the knowledge of terms used in shipping forecasts, and we're going to go through the Beaufort scale, and then obviously the significant to us in small craft. Okay, and then we'll go through a very basic knowledge of highs, lows, and what fronts are. So you've got an idea then. Okay, so visual aids. What is a visual aid? And we're talking specifically about navigation. So it's a nav aid, it's a navigational aid. It's also known as an aton. If you go to the States, they refer to them as atons. So if you hear of an aton, it's a nav aid or a visual aid, depending on which country to country. And it's basically set up for the traveler for navigation, and it's usually for nautical or aviation. There's very few visual aids in respects of lighthouses, buoys, beacons, things like that, for any sort of road travel. But nautical and aviation use visual aids quite a lot. So first type, most common type, is our lighthouse. Then we've got buoys. Buoys have obviously got lights, and lighthouses have obviously got lights. So there's loads of different types of lights. Warning markers. Warning markers are generally not known as buoys, simply because they're not on charts. Channel markers, so we can get in and out of places safely. Safe water marks, well, for obvious reasons. And then there's loads of others, like this is a transit line, you know, so there's loads of other types of visual aids. So if we just go into lighthouses, and there's maybe teaching you guys to suck eggs, but it's a lamp system with lamps and lenses to serve as navigational aid for pilots at sea and or inland waterways. Okay. Now this is the key thing. They mark dangerous coastline, hazard shoals, reefs, rocks, anything that you could hit. Now, especially with new sailors, they tend to aim at lights at night. So it's like light means safe. So as skippers or new sailors, you must remember light does not mean safe. Sail away from light. I don't know if any of you have seen the movie A Bug's Life. I can't help it, I'm going to the light. No, don't go to the light. Okay. They were once massively used, absolutely all over the world, but due to basically the uneconomical version of them, somebody having to stand there and turn it on every night and people being flown in by helicopters to repair them, navigational electronic things are being replaced, such as Raycom buoys, things like that are actually replacing them. Eventually, I'll be surprised if there are any left. Okay, just a little piece of history. Pharos in Alexandria was the first and most major lighthouse, and unfortunately she's gone because of a series of earthquakes, but she was where lighthouses started. So like just a nice piece of history there where they've been going for thousands and thousands of years. Pharos, I haven't got an actual date when she was built, but apparently she was well over 500-600 years old before they lost her. Modern lighthouses, on the other hand, use a lamp and a lens to optic it. Okay, so if you look at this pic, you can actually see, you know, you'd assume it's round. They're anything but round. They're actually shaped so that the lens and the lamp create certain specifics. Okay, and they're your specifics. The lens is designed to create beams, which then give the lighthouse identifying characteristics. Okay, so if I go back one page, you can see that there will be one beam, there would be the second beam, and in this case, there's lots of beams coming out. And that's specific to the design of the light itself with lenses. Okay, So if we talk about those characteristics for a minute, you can have them as different colors. The top one, that's red, green, white alternating. You could have it as just a fixed light. You could have a flashing light on and off. You could have it as a group flashing. So dark, 2 flashes, dark, 2 flashes. So there's a useful table. So if you ever looking and thinking, okay, I'm looking at a chart, what does GP OC3 mean? Well, it's actually group oscillating. So off, long on, off, short on, off, short on, off, short on, off, long on. Oscillating. Okay. Quick flashing, very quick. So these little terms on the right-hand side are what will appear on your chart. So, for instance, the bottom one will give you a Morse and then whatever letter it is. So that's a long, it's a dash, dot, dash, dot, dash, dot. So every single light has its own characteristics. Where do we get that? You remember our book, The List of Lights and Signals. Right in the beginning, we spoke about list of lights and signals. That will have a display like this on the right-hand side for every single lighthouse. And if you buy the South African one, it goes from Namibia all the way around to Richards Bay and beyond. So every single light has this sort of detail. So you can identify a specific light by its characteristics. Okay, charts also provide very similar information. So you've got a lighthouse, on the chart, it will have that sort of information written next to it. What the height of the light is, what it flashes, if there's a horn involved, what it sounds like, all that sort of information is on each chart. Okay, so the height of the light characteristics, specifically if there's an obscured section. So if you've now got something in the way, now if you do any sort of trip up the east coast of this country, a lot of those lights can be obscured because the coastline is so flat. So any obscured section is detailed on a chart. You can also use a lighthouse with the charted height above medium high water spring, and then your eye height to work out your distance from the light. So therefore, you know the bearing to the light and the distance from the light, you can work out a position. Okay, next little topic, buoys. First thing I'll say about buoys is the whole system is controlled by what they call the International Association of Maritime Aids to Navigation and Lighthouses Authorities. Okay, abbreviated, they called IALA. Okay, they have specific colors specifically for daytime viewing. You might not be able to see the cross at the top of this wreck, but you will clearly see the blue and yellow. That's daytime viewing. Okay, then you have a shape at dusk. You might easily not be able to see the colors, but you might well see the shape. And then lastly, they'll have a light for nighttime viewing. Pretty much every single buoy that we will encounter at sea will have them. But remember, not all buoys are floating. There are many, many, many buoys in the world that are actually pylons attached on top of a piece of concrete, and they're not floating. So the first type of buoy I want to talk about is cardinal markers. They're pretty much yellow, red and yellow, all of them. Okay, they are there to show an area where you cannot enter. Marks isolated reefs, shoals, or any navigational hazard that you cannot go into. Okay, and they are fixed hazards. They are there permanently. No, they are also the same all over the world. Doesn't matter which country or part of the world you go to, you will find that these cardinal markers are identical. They might be slightly different welding jobs. They might have a different frame underneath, but the shape and the color structure will be the same on every single one in the world. So if we look at them, there's the 4 types. There's a north, east, south, and west, okay? But it basically means if you go north of a north one, you're safe to pass north. If you go south of a south one, you're safe to pass south. Okay, so 2 arrows up means stay north. 2 arrows down, which obviously means then stay south. Okay, if we look at the easterly one, it looks like an Easter egg. It's an egg. Stay east of it. And if we look at the westerly one, it's like a W sideways, stay to the west of it. So this drawing gives you a nice indication of there's your danger in the middle. Okay, stay north, east, south, or west. So it basically details which compass point we need to stay away from that hazard. Okay, now note, if you look at the drawing, wherever the point of the arrow is, it aims at the black. So the painting of it is where the arrows point. So the northerly, the black's on top, whereas the westerly, where the 2 arrows point at each other, the black's in the middle, and so on and so forth around. So that's your daytime. I can't quite spot what the arrows are doing, but I can clearly see the colors. So all the black's at the bottom, there's no black on top. Oh, well, that's got to be a south then. The lights then. Each of these have specific lights, and again, they're the same the world over. They work like a clock. North is just a continuous flashing. He just flashes all the time. He's either a quick flash or a very quick flash if you've got 2 or 3 next to each other, just so you can identify them. But he's a white, and all of these have white lights. Now, don't be deluded. When these guys say white lights, okay, they do get dirty, and they can be slightly yellow. Saldanha Bay is a perfect example where birds poop all over their lights and they get dirty and nasty. Okay, so we go around, 3 o'clock in the morning, we've got 3 flashes, east. We go around a bit more, south, we've got 6. Okay, but they add 1 long. So it'll actually be 6 short flashes and 1 long. That just means it's really easy to identify that I'm 6. I'm not having to count 6 and then miss 1 and then recount and miss 1. It just makes it very easy. Then we come around to 9 o'clock, and that's fine. It's 9. And then we go back to the top, which is an all white. There we go, flashing continuously. So just that 1 long at 6 makes it slightly different, makes it much easier to count them if you're trying to identify one from another. Then we've got channel markers. Channel markers are red and green, obviously, okay? And they mark routes through hazards and or in and out of harbors. Very, very bog standard all over the world. Okay, we have red cans like this one, and we have green cones. And you can actually see the difference. I'm going to go back again. There's a can, and you can see how they've actually welded pieces on here to make it look more like a cone. So that's a shape for channel markers, cans, cones. Okay, however, the world over is not the same this time. We've got EALA buoyage systems. For EALA A, which is what we fall in, UK, Europe, most of the world's EALA, Australia, New Zealand. Then you've got our EALA B, okay, which is North and South America, okay, and then a little bit Japan, Republic of Korea, Philippines. They're EALA B. They're the reverse. So in region A, you put your red can, your red port on your port side. So you put red to enter a harbor. In B, it's the reverse. You exit a harbor red on red. Okay, so the next time guys are sailing to Rio, there we go, we leave Cape Town. You're actually going to end up in Rio. Don't put your red on your red. You're going to hit the wrong side. Okay, now there are lots of stories, and I don't know if we're going to ever find out what the true reason is. These are some that I know of, okay? The one is the present day system was kick-started into the following a series of accidents in Dover Strait, when a series of ships misread our green wreck marker buoys as starboard hand marks and ran aground, okay, creating another wreck. Now, that was an American thing, and then they moved the lights around. Whether or not it's true, we don't know. More likely, American rivers, when navigation wasn't really a big thing at sea, used red right return. And then that eventually came down and started spreading out, which meant red right return. Whether that's true or not, there's no real data on how it actually started, that we've got an A and a B system. That's too, whether the rivers did it or whether it was because of accidents, it's now what we've got. So that's it. Then if we look at our port channel marker, so this is a Yala A, port on red cans on the port side, green cans on the starboard. If your channel splits like this, you've got a preferred channel marker, okay? This guy here, he's red and he's green, okay? He's a green channel marker, he's a green cone, you see that? Okay, he's saying you prefer you go on this channel because I'm a green channel marker, that's my preferred channel. However, I'm also, for this little channel here, I'm the red can for this little channel here. So it's preferred to port, but little channel here. Now for us as small boats, 9 times out of 10, they prefer us to use the small channels. They don't like us as messing around with big ships in the big shipping channels. They want us to use inshore small channels. So that would, to us, would probably mean that's our preferred. So if you see that sort of thing, have a look, make sure you look at it, and it often says all small vessels use small channel. Big vessel will look at it and go, okay, I can ignore that, I'm just going to go straight. Then we've got safe water marks. Wonderful things. They're just generally a point that you can sail to that'll lead you into somewhere safely. They're the same all over the world, okay? See, the coloring is pretty much similar. A little red dot on top, not necessarily, okay? And as I say, they give you a nice point of entry into ports, into places where you not need to find some sort of transit. They're very, very useful buoys. Landfall is one outside Cape Town. And then the other hand, you've got isolated danger, black and red. Also one outside Cape Town. Okay, they're the same the world over. These always flash 2 white. The world over, an isolated danger flashes 2 white. That's it. Okay, 2 black balls. If you ever see 2 black balls at sea, it means danger. If you're not under command on your vessel, you hoist 2 black balls. Okay, so 2 black balls, not under command, 2 black balls, isolated danger. No choice in that, just stay away from it. New danger. Now that was the one we showed you earlier where it said wreck. New dangers are likely to be wrecks. When you think about it, there's not going to be new rocks growing outside your harbor, but there might well be a wreck. The main thing is they might well not be charted. They haven't put an isolated danger buoy down there. This is something that will not be on your chart. Okay? They are the same the world over again. And they are pretty much flash blue, yellow, blue, yellow. And it's pretty much the only time of any lights at sea you will see blue. Even the police are asked not to have blue lights at sea because isolated dangers need to be seen by navigators because you don't know they're there. They're absolutely new to the environment. And then there's special marks. Yellow marks with a cross on top. Okay, and there are hundreds of reasons for them. I've got a whole list here. Mooring areas, farms, dead ends, pipelines, wrecks, you know, dive sites, overfalls, sewage pipes, hundreds of reasons. But the main reason for having a yellow mark, of course, We use them for racing marks. Okay, that's the main reason. So if we have a look at those ones, let's have a quick little quiz, see how we do here. Which is this cardinal buoy? North, south, east, or west? Let's have a look, see what the answers are coming out like. Getting lots of right answers here. Lots of right answers. Okay. What light does an isolated danger flash? Two white, three white, two red. Yep, lots of right answers coming there too. And Kim, where can I get information about the characteristics of my lighthouse? From a chart, from the list of lights and signal, from an electronic chart, or all of the above? Yep, again, lots of right answers. So west, that's a westerly cardinal. Black's in the middle, yellow and on top and bottom. Two arrows pointing towards each other. Two whites, always flashes two whites the world over. And you can get lighthouse information from your chart or your list of lights and signals or your electronic chart. No worries. Okay, meteorology. Change the topic completely. First thing, what is it? It's a branch of atmospheric sciences. It's the most inaccurate science I know, I'll be quite honest, but it does atmospheric chemistry, atmospheric physics, and then a major focus on forecasting. Okay, so they do take physics and chemistry into account when trying to put things together. Okay, where do we get it from? The biggest sources of information actually come from national meteorological offices, SA Weather, the Met Office, US weather, etc., etc. They spend the most money on research. Okay, that research they do is then converted into information that we can get. Things like the grid files, good at information in binary form that we use. Weather charts. Weather charts are a thing that not a lot of people are using these days, but it's monthly information on a certain area of the world in a certain month. And then you got web service like WindGuru. A lot of people use WindGuru, predict wind, that sort of thing. You can obviously get it through your HF, your VHF, or your Inmarsat-C. You look in your list of license, list of signals, your signals book. It will tell you what time of day and on what channel it is broadcasting weather. Navtech sends it out. Here's a nice Navtech report for Northern Ireland. Okay, occasional gales, things like that. Beaufort scale. Now, if we go back to the Navtechs, it turns around, it says gale 8 at first in number. Thames Northwest 527. How can it say it's a gale that's just 8? A gale is not just 8, it's much, much more. It's because they are referring to the Beaufort scale force. Okay, its full name is the Beaufort scale force. It comes from a very long time ago where Admiral Beaufort literally worked out that he could tell his naval ships, whatever the sea state was, they would have certain sail plans. So the whole Navy could sail to one point at the same time. So instead of arriving one at a time and getting beaten up, they all arrived together. Okay, so the Beaufort sail refers to the force. That's the 7 and 8 that I was reading off the Navtechs. So 7 and 8 is actually saying it's knots of 28 to 33, 8, 34 to 40 knots of wind. Each one is given its own name. So you've got calm, which is almost no wind, light airs, light breeze. It is related to what is happening on the water. Large wavelets, so if we look at force 3, 7 to 10 knots, large wavelets, crests begin to break, foam glassy appearance, perhaps scattered. If you look at the sea, that will actually tell you it's a force 3. It's not the wind knots, not the wind strength. Okay, so force 4, 11 to 16. So if we look at force 4, what we'll be looking at is small waves becoming larger, frequently with white horses. So you're actually looking at the sea state to get a wind prediction of what you're actually in. That's how the Beaufort scale works. Okay, so it's sea state to derive wind speed. So if you lose your instruments, you can still write down what force it is by what the seas is. So you look at a 10, very high waves with long overlapping crests. The resulting foam in great patches is blown in dense stacks. Well, I mean, you know you're going to be in some sort of storm, but you'll be able to say in your logbook, force 10. Okay, what creates all that weather? Highs and lows and fronts. All weather systems are basically the movement of air from a high to a low pressure. You pour water, it's going to go from up to down. Air works the same way. You go from a high to a low pressure. Okay, low pressure is where air is rising. Okay, and it's creating a lower pressure at the bottom, so air moves in and goes up. High pressure is the reverse. High pressure is dropping and it's pushing out. Okay, don't look at the way the arrows are drawn in these particular pictures. We'll talk about that in a minute. Okay, generally low pressures are associated with poorer weather, high pressures are associated with better weather. Okay, purely because of the amount of movement. Okay, so we're talking about pressure here, aren't we? That's pressure, that's pushing air pressure down, that's lifting air pressure up. So if we take air pressure as an average of 1,000, that's what they call it, 1,000 millibar. Okay, when it's lower, it's going to start dropping. When it's higher, it's going to start pushing up. Okay, now due to the rotation of the Earth, the pressures turn in different ways around the world. Okay, this is called the Coriolis effect. It's just the way the Earth spins. Okay, in the Northern Hemisphere, a high pressure will turn clockwise, whereas in the Southern Hemisphere, it will turn anti-clockwise. Basically, there's the widest point of the Earth, and it's going to turn slower at the faster at the widest point. So, north and south pressure changes. Low pressures turn in exactly the opposite direction. So, as we said, the high pressure in the Northern Hemisphere is clockwise, low pressures are anti-clockwise. Southern Hemisphere, low pressures are anti-clockwise. Sorry, high pressures are anti-clockwise, so therefore your low pressure will turn in the opposite direction. It will turn clockwise. Now, if we think about Cape Town very briefly, we have a southeaster that blows when it's nice and sunny. That's turning counterclockwise. It's blowing up north out into the Atlantic. That's turning counterclockwise. Then, when it gets nasty like it is now, the wind comes from the northwest. That's turning clockwise, and it comes and hits us and brings all the horrible weather in. That's a perfect example of highs and lows turning in opposite directions. Okay, then you've got fronts. Now, when you bring a low pressure in, it's going to have weather with it. So fronts are the leading edge of that pressure system. It's a beautiful picture of a front here. You can see how the cloud is lifting. It's just being pushed up and creating cloud. Okay, and it tends to be followed by very poor weather. You can see it's a lovely day there. It's getting worse here on the right. The reason for that is you get the cold air moving in. The warm air, which is naturally going to rise, because hot air rises, okay? And it pushes this cold air in. Warm air rising causes condensation, and that's what causes our rain. And it gets cold because the cold air pushes the warm air up. That is the basis of all fronts the world over. Now, if you look here, there's got a nice little arrow, 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 arrow. When we look at a synoptic chart, arrows dictate or show on it where a front comes from, what it looks like. Okay, so it pushes the hot air up, creates condensation, i.e. clouds, creates rain. We get rain in a cold front. So we get cold and rain at the same time. The rain is caused by the warm air being pushed up. So if we look at this synoptic of Australia, we can look at the two different pressures there. There's your high pressure. It's 1,025 millibar, very high. Okay. Down here, we see a low pressure. It's 983. It's pretty low. It's even lower here, 970. Okay. Here we can see the front pushing through. There we see a front. There we see a front, little spiky things. That's where the cold air is coming in and pushing the warm air up. You'll notice that these millibar lines are closer together around a low pressure and much further apart around a high. The closer they are together, the stronger the wind. So if we start seeing them really, really close together on a synoptic chart, you know you're in for a lot of wind. If you're sitting up here in Brisbane, you know it's going to be a lovely clear day, stinking hot with almost no wind. If you get up here to Great Barrier Reef, lovely, lovely weather. Down here in Tasmania, you don't want to be there. Okay, so how are we doing time-wise? Yep, we're getting nicely through it. So if you see your pressure dropping on your barometer, are you going to expect poor weather or expect fine weather? You're going to go run and hide in the pub, or you're going to plan a sail to France to go and buy some wine? Or is it A and C or B and D? Someone's hedging their bets. They've gone for D and E. Okay, so got a couple of odd answers coming in there. I'm going to go back one slide, if I can. If we look at the barometric pressures here, as the pressure drops, we'd expect worse weather because you've got a low pressure. There's 1,025, there's 983. So if you see your pressure dropping, you know it's coming in. Okay, you're planning a trip to France. First check will be fuel, food, crew, or weather. Lots of right answers coming in here. And then a high pressure in the northern hemisphere turns which way? Getting lots of different answers there. Okay, so basically if you see your pressure dropping on the barometer, you can expect poor weather, go and hide in the pub. You do not want to be going to sea in any way, shape or form if the weather starts dropping. If the barometer starts dropping fast, it means that there's going to be weather coming in. The first thing you always check before going to sea is your weather, without question. Without question. It's the one thing that can really get you in trouble. And in the northern hemisphere, the high pressure will turn clockwise. If you think about this, our southeaster down here, that turns counterclockwise, that's a high pressure. It's the opposite in the northern hemisphere, that's clockwise. Okay, so I mean that's just really scratching the surface of meteorology. I mean, there's degrees to be done in it. You are, as any sort of skipper or person of sea, expected to actually know your Yala buoys. That's not, it's a crew included. It's up to the skippers to actually teach their crew about Yala buoyage. You don't need to know what the lights are for every single buoy, except the Cardinal Marks and Isolated Danger. Because Cardinal Marks have the same lights and Isolated Danger have the same lights the world over. The lights on things like channel markers can vary depending on port to port or channel to channel. I use Mariners on my phone. We've spoken about it before. So Buoys, lights, Beaufort forces, Douglas forces, the whole lot are all listed on there. It's a really, really useful app. Okay. And most of these things are now available electronically, as we've said before as well. Okay. For weather, I use WindGuru Pro. I use Pocket Grip, Predict Wind Pro, and Windfinder Pro. You'll find that you'll learn that your certain apps will work better in certain areas. The Pro versions tend to be written by the professors versus the freebie versions tend to be written by the undergrads. The second thing is the Pro versions tend to be within a 12-hour of the prediction versus the free versions are often a prediction is done 24 hours ago. So just the predictions are more updated and they're done by better meteorologists. If you want to pay the money, you get a better forecast. It still doesn't mean to say they're right. It just means you're getting a better forecast. Okay, so next week, we'll talk about passage planning. So the preparation of passage planning, meteorological considerations, the use of waypoints on a passage plan, and, you know, the keeping a keeping a navigational aid. So basically, we're looking at what we've been creating all the last couple of weeks, session 9. Okay, so let's go for the unmute, see how we're doing. Anybody got any questions? Where are we now? Any questions on this evening stuff? Goodness me, no questions.
Wavy, there's one from chat. Why not mention weather routing?
Okay, weather routing is it's quite a different thing. Weather routing is if you're going to take a longer route, say across the Atlantic, and it's an ongoing information source. So for instance, if I'm going to route a yacht across the Atlantic, they will be given constant information updates on what the weather is, where they should be going to avoid it, that sort of thing. And it can go right down to, depending on what people want, what their sort of sail plan should need to be. It's quite a detailed subject, and we could probably do an entire hour on just weather routing. I don't know if that answers the question, or if I'm missing the question.
Okay. Then there's another one from Walter. Does low pressure always go left to right?
Okay, good question, Walter. Yes, low pressure will always start in the west and move around the globe towards the east. The reason for that is because the globe spins in the opposite direction. So the sun will always rise in the east and set in the west. So the wind will then be moving in the opposite direction of the world. So if you want to know what's going on in Australia in 2 weeks' time, you have a look at what's going on off Argentina. So when we look at what's going to happen in Cape Town, we look at what's happening off Uruguay, because that tells us where the lows are developing and how they're going to move across the Atlantic towards us. Because effectively the world is turning continuously from towards that side of the world. And obviously the air is not connected to the earth. It moves separately to the earth spinning. That's a good question, Walter. So you'll always see low pressures. The other thing that low pressures do is they act as a cog between high pressures. So if you think about a high pressure in the North Atlantic or the South Atlantic off here in Cape Town, turning in a counterclockwise direction, and then there's the Antarctic high also turning in a counterclockwise direction, the two of them can't turn the same direction at the same time and meet, because they're both two cogs of a machine turning the same way. So then you get a low pressure moving between them, a cog turning in the opposite direction. You can't have two cogs meeting, turning the same direction. They don't work. That's when you get those bands of absolutely no air, when you get two high pressures meeting. So a low will then create the opposite direction cog. Any other? I can see a question here. Cyclones in the northern hemisphere, hurricanes move west to east. Okay, hurricanes are a different animal in itself. Okay, hurricanes are actually a tropical revolving storm. So hurricanes, cyclones, monsoons, they're all a tropical revolving storm. Okay, so they move under their own steam. They are not part of the highs and lows of a normal weather system. That's why they're particularly unpredictable. That's also why they can suddenly veer off course. So this is one of the reasons why hurricane or tropical revolving storms as a whole are particularly difficult to predict, because they do not follow the normal systems that we understand. Another good question. The only thing that we do know that unequivocal, they tend to arrive with certain conditions. So you actually have a hurricane season in the northern hemisphere, for instance, in the Atlantic, or you'll have a cyclone season in the Indian. There's not a huge amount of, well, there's a lot of knowledge about them, but there's not a huge amount that people are actually accurate with them, which is why they're still hitting them like the hurricanes are still hitting the Caribbean and still hitting the States, and people can't predict exactly where they're going to hit, because they're just not that much knowledge about them, because they are so unpredictable. That's another nice question. Okay. Any other questions, guys? There's usually a few more weather questions, but the main ones, I think, the what about hurricanes? I've never thought about that one in the weather presentation at this level. It's not something we in Cape Town have to worry about too often, thankfully. I think the people who worry about hurricanes most in Cape Town are the guys who are making the Southern Wind boats. Not the Southern Wind, the Robertson Cane boats. One of the things you can take into what we did with the boys is, if you look at the next Mechanos race, and you look at the Saturday race when we go around the cans and then we come up and down and what have you, there are many cardinal marks around Saldanha. There's a lot more even than when I was last year, and I've noticed because of the size of the growing mussel beds, they're adding more and more cardinals. They're adding more and more areas that they're cordoning off. So it's worth knowing those cardinal buoys just before you do your next Mechanos race.
Wait,
Leo?
as a point of interest, have you seen any of the South African synoptic charts recently?
Yeah, I look at them quite regularly.
Have you also noticed that they're missing the geostraphic wind speed chart?
They're missing a few bits and pieces these days. They're actually getting worse and worse. But yes, I did notice that when I first got back. They've also changed the way they're presenting them, and I think a few other things have been dropped off them.
I see they've changed the format of the chart, but because I actually wrote to them and complained about the way they labeled the degrees of latitude and longitude, and I also told them that they've missing the geostraphic information.
Yeah.
And it was on for about 2 or 3 updates, and then it's gone off again.
Yeah, no, the South African weather, the one thing I was thinking of specifically was the latitude and longitude. They just stopped labeling it.
They're labeling it, but they had it labeled very terribly, and they were marking the latitude and longitude in 15-degree lines and labeling it in 20-degree intervals.
Well, I pulled one out the other day, must have been Friday or Thursday last week, and it just had no lat and long.
Oh, I haven't seen that yet. I'll check again.
Yeah.
And then the other thing, do you ever get the charts directly off of the Cape Radio broadcasts from SSB or not?
I haven't done it for a while, to be quite honest, just because of the advent of satellite communications and grid files. I used to do it a lot, and then you'd fill a form in, and then you'd draw your own basic synoptic from that, from SSB. I used to do that quite a lot, especially in the UK, and that's how they did their forecasts. But I haven't done one for a very long time, I'll be quite honest.
Okay, and I was just curious because the book, the radio book, is very inaccurate as to when they broadcast, but B, the chart that I receive off the radio is terribly ghosted. I don't know if it's my radio or if it's they broadcasting with a ghost in it.
I'll be quite honest, the forecasts on VHF, depending on which channel you're on.
No, this is the synoptic charts I'm specific on.
Yeah, no, but I was saying the normal broadcast have been, I still use them for teaching purposes and things like that, so students can find them and listen to them and what have you, and then I just listen for weather forecast. But I find them still to be pretty accurate. As I said, I haven't tried to get one of those for a while, but the VHF stuff's still pretty much on time. And Cape Town Radio are pretty much smack on with, I think it's 15:33 is the one broadcast, and it comes out at 15:33 on the dot. So I'm not sure about the SSB ones.
The SSB ones that I've listened to they're missing frequencies, and sometimes they miss times, and the Navtex ones come out, that weather text that they read out on Navtex was quite good, and that's regular. But
I'm quite surprised because it's the same bunch of people doing the broadcast.
Yeah,
it's Cape Town Radio.
That's what I thought. I want to try to get hold of them and find out, because the weather chart that I get that you download it's a terrible quality. And it's not for lack of radio signal.
Oh, I honestly, I don't know the answer, but I'd give them a ring. The Cape Town radio tend to be very open to anything, and if you're having an issue, they're actually really, really good at I was having an issue with my SSB or my HF on a boat called Amalia, and they were really, really good at getting me advice to getting it up and running well. And then she gave me great comms across to St. Helena. So they're very open to helping. They're a good bunch there.
I'll give them a try and see. You say it's not lack of signal strength. I mean, it's flat out here, but the signal is terribly ghosted.
Yeah, the guys might have a very clever way of changing the signal, changing the way you receive it, and then suddenly you're getting excellent quality. I just give them a ring. I mean, last time I couldn't get through to them, I gave them a ring and they said, try this, try that, do this. And then sure enough, we got 5 out of 5 comms. So they were very good.
Cool, thanks.
Okay. I did see something there on the chats from Joanna. Why are R and C worried about hurricanes? I'm not sure what you mean by R and C. Joanna, do you want to just...
Robertson and Kane, probably.
Yeah, it's Robinson and Kane, Wavy.
Oh, okay. Because when hurricane hit the Caribbean 2 years ago, it wiped out half the fleet, and the guys are desperately trying to make boats to get them back there. So it's literally a case of I think the guys were producing 200 and something boats a year, and now they've been asked to produce 300 and something. So it's just literally, it's just the pure number of boats they're having to make. It was a facetious comment. Hurricanes destroy boats and it's not nice. I don't think anybody likes the thought of having a boat in the Caribbean destroyed by a hurricane, or anywhere for the world, doesn't matter. Okay, guys. Well, Kerry, don't seem to be anything else coming up.
No, it looks good.
Yeah. So I think let's call it an evening on that. We want to close the session down. Guys, thank you very much for coming again. And we'll see you this time next week. Hopefully our temperature and our weather improves a little bit. It's absolutely freezing at the moment.
Awesome. Bye, Patrick.
Hi, Patrick. You want to say something, Patrick? You're missing something.
No.
Cheers. Thanks, guys.
Thanks, Patrick. See you soon. Bye.